In this quick video, we're looking at simplifying expressions with addition and subtraction, and the things to write down would be all the things down here with little bullet points next to them. So we're talking about like terms and non-like terms. Basically, it's apples and oranges. So you're looking for terms that have the same letters in them. Doesn't matter about the numbers, but they have to have the same letters. And those letters have to be in the same combination. So for example, here's an apple and a banana. Okay, those things are different. But if I had a banana and an apple, that's the same as saying an apple and a banana the other way around. It's the same fruit, it's just the order is different. So when we talk about algebra, these two things are actually the same. So something like A, or I'll use B actually, because BA is the same as AB. And that's because B times A is equal to A times B. If you think about it with numbers, right? Let's pretend B is 3 and A is 2. Well, you know that 2 times 3 and 3 times 2 are the same thing. So the order doesn't matter in algebra. What matters is that you have the same letters in there. The order doesn't matter. But things like x cubed and x, there's one there, x squared and x are different because they don't have the same number of those letters in there. So we're going to look at like terms. What we're going to do here, we've got 6 examples. So we've got the first one. It says, which of the following are pairs of like terms? 4x and 7x. What you need to think about is, are the letters the same? Well, yeah, they've both got an x. It doesn't matter that you've got 4 of them and 7 of them. You've got x's. You don't have other things in there. So 4x and 7x are like terms. They both have x. For part B, we've got 5ab and 9b. Well, here we've got an AB. This term has an AB. This one has just a B. It doesn't have an A with it. So these two things are not like terms. And that's because in order for them to be like terms, you would have had to have an A on there. So it's like an AB and a BA. So they're not like terms. Part C, X and 12X. They're all the same type of letter. They're all X's. There's one X here and 12 X's there. So they are like terms. D, 8 and 8z. Now you might be thrown off because they've both got 8 and you're like, oh, they're the same. Remember, you don't care about the numbers. You only care about the letters in each term. And in this case, you've got a constant and something with a z. So these are actually not like terms because you don't have everything here with a z. Next thing, E. We've got h to the power of 3 and 6h to the power of 3. Now these are the same combination of letters here. The h cubed is the same. Doesn't matter about the numbers, remember, but we've got a h to the power of 3 in each term. So these are like terms. And the last one, we've got an xy and an x squared y. Now this is where you might think, oh, these are the same. But you've got a little power here on the x. Doesn't look exactly the same. Okay, this would have to be xy and xy for them to be the same. So these are actually also not like terms. So that's finding like terms and not like terms. Now what we're going to do is we're going to combine them. Okay, you can simplify expressions by adding or subtracting like terms, which is what we call collecting. So it's like if you had a bag of fruit and you had apples and bananas, you'd put all the apples together and all the bananas together. So you're collecting what we call the like terms. So what we're going to do is look at some examples here. So I'd definitely recommend you write these in your book. So the first one is we've got 4y plus 7y. Well, these are like terms because they're the same object. Think about it as like a Y word thing, like yachts. Okay, so you've got 4 yachts plus 7 yachts. How many yachts altogether are there? 7 plus 4, there are 11 Y's altogether. And it's like imagining this. There's 4 of them and there's 7 of them. How many have you got altogether? 7 plus 4, you've got 11 of them. So that's why we've got 11 Y's. This one says we've got 2mn minus 4mn. Now think of the mn as being like an object, okay? So mn is like a little, there's 1, there's 2, so this is 2 mn's. Take away 4 of them. Now if you thought of these as like little M&Ms, if I take away 4 of them, you'll realize I'm taking away more than what I had. In fact, I'm taking away 2 more than what I had. So this becomes negative numbers. I end up with 2 mn's less than what I started with. So that's why it's negative 2 mn. The next example is not all of these are like terms. This guy is, and this guy is, but not the plus 4. That's not a like term. So we've actually got 2 things happening. The first thing is we've got 8 A's happening. And make sure you take the sign that's in front of the term. Remember, that's included in a term. So this is 8A. Take away 3 A's. 8A, take away 3 A's. That will leave you with, if you take away 3 of these, you'll have 5 A's. So 8A, take away 3A is 5A. And you'll notice I didn't actually do anything with this thing because it was like not involved. It wasn't the same. So because I did nothing with it, I literally just write it down after the bit that I did. So I collected the bits together that were like terms, and then any other bits that we didn't do anything with, you just write them down. So that's the first part. Second part here is simplifying again by collecting like terms. This is where I love to use, colors or like different shapes. I'm going to use different shapes. So first thing I do is I find all the like terms. I'm going to do circles around the x terms. Remember to include the negatives. And then I'm going to do maybe like a square around the y terms here. What that does is it helps me to see the parts that I'm looking at. So the first thing I'm going to do is the circles. I've got 4x. I'll just do it over here. Take away 9x, just the circle parts, 4x, take away 9x. I know that 4 take away 9 is negative 5x. So imagine you have 4 x's, you take away 9 of them, and you've got 5 less than you started with. So that's negative 5x. What I then do is I cross that out because I've done that bit. Now I'm going to look at the square part. I've got 3y's, plus 3 means that you've got 3 of them, it's positive. Plus 2y. You'll notice I write down the signs in the front in my little equation. 2 and 3y's, well, that would be 5y's altogether. And see, it's positive, so it's a positive answer, 5y. What you've done, and I'll cross them out because I've done that. So what you've done is you've collected together all of the x's and the y's. The last part is this part here. We've got, again, I'm going to do the same thing. I'll do this in red this time. AB. We've got another AB term there with a plus 3. This is an A on its own, so I put a square around that. And this minus 7, see it has no letter? It's actually different again, so I'm going to put a little triangle. So I'm going to go through my different shapes first of all. The circle, 6AB plus 3AB, that's the circles. 6ABs and 3ABs. Well, altogether there would be 9 of these little ABs. The next thing to do is to go through the square. There's no other square, so actually I don't do anything, I just write that down. And there's one triangle left, there's no other triangle to collect it with or to simplify it with, so I just cross that out and write it down. So what you've done is you've taken that expression and you've simplified it by combining the AB terms together, but then by leaving the other terms because there's nothing else there to combine them with. So that's the idea of finding like terms and combining them or collecting like terms to simplify an algebraic expression.